Hello, my name is Brennan Doyle. I'm a solution architect at the Google Cloud, focusing mostly on media and entertainment vertical. I have with me here my friend Greg Denton, who's a software engineer on our render team. We're going to talk to you a little bit about OpenCue and rendering. First thing we're going to do is we're going to talk a little bit about what problem are we trying to solve. And then I'll introduce to you two different ways that we can solve it on GCP. And then we'll do an overview of a new tool that we've open sourced in collaboration with Sony Pictures Imageworks called OpenCue. And then we'll do a live demo, fingers crossed. And then Q&A at the end. So what problem are we trying to solve? So basically, there has been growing pressure of new content being created. So with Hulu, Netflix, all these different content creators, there's been an explosion in unique scripted content. So the need for creating graphics has grown. In addition to that, if you look at what we were doing back in the 1990s, Titanic, for instance, had 300 shots in it. The last Avengers movie had 3,000 shots in it. So each individual project that comes out is having like a 10x growth in the amount of graphics that are needed to finish that project. A somewhat popular animation studio claims that one of their more recent films took them about 33 hours a frame to render. And when you look at a 2-hour movie, you're looking at 24 frames a second, 60 seconds a minute. 120 minutes is about 172,800 frames. That's not only math, but those are large numbers. When you start to multiply those by how long it takes per frame, you're looking at 5,702,400,000 hours for a single revision of an animated feature. And time equals money. So how do you go about orchestrating these things in a way that's efficient? And that's what we're here to talk to you about today. So at Google Cloud, there are two ways we can help solve the rendering crisis. One of them is using software as a service. So it's much easier for you to set up. It's generally targeted towards small and medium-sized businesses. And the other is building a custom pipeline using infrastructure as a service. So the two things I'll talk to you about today are Zinc Render, which is a turnkey solution for small and medium business owners to do rendering on the cloud, mostly for burst rendering. And then also OpenCue, which is basically for larger studios that have custom pipelines. How do we at Google help you to build something that'll solve problems for you? So a little bit about Zinc. Zinc is designed by visual effects artists for visual effects artists. It makes it extremely simple to render. There are several components that go into a Zinc system. Basically, it integrates with your existing rendering software. So if you're using any of these following tools, it will work with these. And it's very simple to kick off a job and render it in the farm. Basically, what you end up with is a client that manages all of our transfer to the cloud from your local workstations to the cloud, copying all the data that is required for your rendering. You install plugins inside of your host 3D or 2D application. And then there's a web console that allows you to manage your jobs after they've been submitted. So you can move around priorities, do troubleshooting on jobs, things of that nature. It's a very simple architecture. Zinc would be for yourself. A lot of what we're building out for you is contained within this compute engine node right here, which is basically everything is a black box behind the scene happening for you. You don't have to worry about that infrastructure. So basically what we're doing is we're setting up authorization for your users and then managing all your transfers and renders. So infrastructure as a service is more what we're going to dig deeply into today and take a look at OpenCue. But basically, the larger studios that we work with generally have very unique pipelines that require them to do very specific things. So they need a tool that is custom built. So in that world, everything is a resource. Basically, each piece of the puzzle that is required to be put together for rendering is a resource that you need to orchestrate. So you start with your render workers, which are basically your VMs in various sizes and flavors. And then you can add your persistent disks for storing data, additional disks that might be needed for holding onto your pipeline information, things of that nature. Object storage as a backup, and all these need to be orchestrated. So when we stick them together, we end up with something a little bit like this. So rendering VMs are the root of what we're trying to achieve, is being able to render frames. We have some kind of a storage, which is where we are storing all of our assets that are going to be prerequisites for renders. We generally have some kind of NFS file server that is required to either host your textures or your pipeline for software and such. There's when we're dealing with a hybrid connectivity, we almost always are using a read-through cache. And then there's some kind of license server that needs to be created and some way to manage your users' permissions, as well as something for logging, which we use Stackdriver for that, and your asset management database. And we're here to talk to you about OpenCue. So for what we build here today, we're using Terraform templates to build out our infrastructure and to manage infrastructure as code, so it's easy to spin up, modify, and move around to different places if we need it. So let's talk a little bit about what is OpenCue. OpenCue is a render orchestration layer or a queue management system that we've partnered with Sony Pictures Imageworks to release to the open source community. So it's available for you now on GitHub. I'll provide some links here in just a bit. It has been used by Sony on hundreds of films. It has been used in various different deployments as well, on-prem, hybrid, and on the cloud only, and has scaled to many, many machines. So OpenCue can work in a variety of architectures. This is not a tool that we've released that only works on Google Cloud. It was developed in an on-premise, there we go, way of working, and you can see how it would function here. It's basically used to distribute the thousands or hundreds of thousands of frames to all of the render hosts that you are utilizing. It's also been used by them quite consistently for hybrid deployments. Here is an example of a hybrid deployment. Sony last year was discussing they are pretty consistently spinning up like 60,000 CPUs in the cloud and managing them with OpenCue. So the deployment we're looking at here today is basically what we are calling a virtual studio. So at the moment, Greg's going to do a demo here in just a bit. He's running a virtual workstation out of Oregon that is connected to his laptop running a software client from Teradici and a protocol called PC over IP. So if you were setting up a studio from scratch, it's likely that you would want to use something like a Zero client, which is not a computer, but just a device that allows you to connect to that PC over IP stream and to stream things back and forth. You need some way to connect to Google Cloud. In this instance, we're using the public internet. If you were in production, you would be using either Cloud VPN, a dedicated interconnect, or you'd work with one of our partners to share a dedicated interconnect line. So again, the heart of the matter here is a virtual workstation running on Google Cloud, which has an NVIDIA T4 processor in it. There we go. And it is how we're going to drive our Maya scene file demo. And behind that, we're only using a single machine here, so we're not working through a connection broker, but a connection broker is a layer that allows your artists, if you have hundreds of artists logging in to a single point, it directs them to their particular machines and also helps you to manage their permissions and login data. So today we're running our storage off of an Elastifile scale-out file system, which is able to tier to cloud storage. So you have a combination of ability to customize it for high speed and also use cloud storage for low-cost backup data. We also have a license server running in the cloud, a very small Linux VM, which is serving up our Maya licenses and V-Ray, which we'll be doing for rendering today. In addition to that, we have our QBot server. QBot server is a piece of OpenCue that I mentioned earlier. It is managing the distribution of the jobs. Maintaining the state of our database is an OpenCue database running on CloudSQL, which uses PostgreSQL. And then we've got a group of render workers in the background. So again, we've orchestrated all of this using Terraform, Packer, and Docker, and are currently working on making those scripts available to everyone through open source. So the types of things the costs that you will incur in this kind of system are all listed out here. I won't go through them. I'll let you take a picture and think about them later. If at the end of this conversation, totally happy to answer any questions that you have. We also have a booth on the far side over there if you want to come and have a little deeper chat. We're way up against the back wall there by the gaming team. So let's talk a little bit about the architecture of OpenCue. So OpenCue has several pieces. We have the, let me see if this works. There we go, the QBot server. QBot server is running right now on a VM in Google Cloud Platform. It is a Java service that maintains the distribution of the jobs and also enables you to log in with a GUI and to see the state of your current queue. There is the PostgreSQL database that's running in the background. Those two are communicating to maintain the list of what jobs are active and where all the log files are residing. There is this RQD render host over here. These are our managed instance groups, which are going to be doing the rendering for us. They're running an RQD process and communicating over these ports back and forth to the QBot server. In addition, on our artist workstation, we have a couple of things. PyQ is a module that enables us to communicate between QBot and the render hosts and the artist workstation. We have a tool called Q GUI, which is the interface for seeing the list of jobs that are running, how we prioritize those, and how we assign jobs to particular render hosts. In addition to that, we have a tool called PyOutline, which is assisting us in submitting jobs. OpenCue ships with a plugin for Maya and Houdini and Nuke, Maya and Nuke, which enables you just from the interface to pull down a menu and say render to OpenCue. Also, there are example scripts on how you could build them for your own customized pipeline. So since it's open source, if you know some Python, you can get in there and script your own plugins. And then there's a submit application, which is running inside of our host tool. So just talk a little bit about the infrastructure that we're seeing and how we're orchestrating it. To configure and build our render hosts, we're using Docker images. So basically, those Docker images are scripts that allow us to define all the prerequisites, libraries that need to be installed, as well as all of the third-party software, and in some instances, links to where you can check out licenses. Those are stored in our container registry, and when we launch a machine, we're launching an instance template, which is reading in that Docker file. We also have went the wrong way, pardon me. We also have the ability to resize our render hosts. So at the moment, what we're doing is we're doing that manually in this instance, but the logic is there that if you wanted to integrate your own instance or work manager, that would look at the size of your queue and automatically scale your managed instance groups and look for health checks and make sure that you've got the machines you need. It's quite straightforward to put something together there. So I think that covers just about an overview of OpenCue. Why don't we dive in and take a look at the tool itself, and I'll hand it over to Greg.
All right. Hi, everyone. Thanks for coming out. Yeah, my name is Greg Denton. I'm a software engineer here at Google Cloud in the media and entertainment rendering team. And so if we switch over to the demo box, we'll jump right in and go ahead and launch Q GUI. So like Brennan was talking about, Q GUI is the primary application used for monitoring and managing the render farm. It's a PySide 2 Python application, and it's going to communicate back with QBot, the central server, over gRPC. And if we look at it right now, there's absolutely nothing to look at because we have no jobs. So we'll jump over to a shell and go through launching some jobs. So there's two APIs. There's a general purpose Python API that's used primarily for just any kind of interaction with QBot. Anything you can do in the UI, you can do through the API. And then there's also the PyOutline API. PyOutline is going to help build jobs. It gives you a lot of functionality to orchestrate multiple jobs together and string them together and submit them. So this is just a simple Python script that's using those two APIs. We'll go ahead and run it. It's kicked off 3 jobs to the farm, and you can see that they've shown up over here in Q GUI. And now that we have some jobs, let's talk about what a job actually is as far as OpenCue is concerned. So a job's broken down into 3 separate levels. You have the job, and that's really just a container for the submission. And if we click on one of them, we'll see that it hosts information about what user submitted it, what facility it was submitted from, what show it's for, what shot, that kind of metadata. And then if you descend down to a separate level, the next one down here is a layer. So a layer is going to be, you can think of it as a command to run with a frame range associated with it. You can have multiple layers populating a single job and dependencies set up between those. And then the layer also is going to keep track of the requirements for that job. So if you want to say that this type of command is going to use 4 cores in this example, that's where you're going to set that. Same for memory and GPU requirements. The next level down is going to be the frame. And the frame is going to be the individual instance of that command with a single frame or frame chunk, depending on how your submission's set up. And it's going to be the command that actually gets run on the host itself. So we can see these guys are all running and kicking away. It's going to keep track of things like your runtime, the exact amount of resources that are used, and all those stats are then bubbled up to the higher levels, so you get a summary view of what has actually been running. So QGUI is actually built up as two separate applications. You have Qtopia, what we're looking at here, and QCommander. So Qtopia is more made for a single artist looking at their jobs, trying to see if their submissions are running, when they'll finish, are they finished, any errors, that kind of stuff. QCommander is more made for a admin or render wrangler to be able to get a higher level view of the farm, be able to have a lot more controls over the management of the farm. So as we dive a little deeper, we'll jump over to QCommander. And the first thing that we're going to take a look at here is the monitor queue view. So this is just a high-level view of everything that's currently active in the farm. And you'll be able to see this across all users. And it gives admins the ability to group jobs that are similar and control them all together. So for instance, if you wanted to change the priority of multiple jobs altogether or change the requirements, you could do that from here. And so the next thing that we're going to go over is kind of how, what groups everything in OpenCue. And so the highest level object is a show, and all jobs are going to be submitted to a show. You can see some really simple information about what kind of cores are running, what frames are running for the show. We only have a single show here. It's the testing show. And we can do things from here, like set the maximum number of cores, minimum number of cores for jobs in that show, enable and disable booking, all that kind of stuff. All right, so we've gone over jobs a bit. Let's talk now about hosts. So if we open up the monitor host view, and we'll refresh this to populate it. Come on. This is going to show us all of our render workers. So the render workers right now are all configured to be identified by their IP address. And you can also have them configured to be identified by their host name if that makes more sense for you. It's pretty customizable from that point of view. And we can see that we have like 3,000 render hosts all up and running, thanks to Adrian's demo from before. And they're all still kicking. So this view is going to give you a lot of information about what type of host you have. All of our hosts here are running inside a single managed instance group. And like Brennan was talking about, that's running out of US West 1. And they're reporting that they have 4 cores. All of them are idle right now and 30 gigs of RAM. So this is counting the physical cores on the box. So that correlates to an 8-core, 30 gig, an N1 preemptible 8 machine. So the other information that's useful here is the ping time. So it's showing you when was the last time that machine checked in. If that goes beyond a certain threshold, Qbot's going to consider that machine down and stop dispatching any additional work. And if there's any work that was running on that, that'll get moved over to another host. This works well for a preemptible workflow because our managed instance group is going to go ahead and replace any instances that get preempted. And then Qbot is going to see that preemption and reschedule the work for you. So works entirely in a preemptible fashion if you want. And So let's go ahead and go back to Qtopia here. And we have a bunch of our jobs have finished, but we have a few that are still running. And if we go to our hosts, and let's sort this by what's idle. So what I'm looking for here is a host that's actually running something. And one of the cool things about OpenCue is it has a way of dynamically allocating slots for jobs to run. So like I was talking about, all of these hosts are 4-core hosts. And let's say if you submitted a job that's only going to require 1 core, OpenCue is going to carve out what's called a proc, and that's what we're showing down here. And it's only going to carve out whatever the job requires, leaving the rest of the procs available to be used. So, for instance, you could run 4 1-core procs on a single host, or two cores, however your job and the dispatcher decides to do it. So we have jobs and hosts now covered. How do jobs actually get to hosts? For that, we'll start talking about how do we group hosts. So there's a concept called an allocation. And an allocation is really just a mechanism for grouping multiple hosts and controlling them together. So we can see that all of our render hosts right now are running inside this local general allocation. And that's going to be identified by a facility where the host is actually running, and then a single tag that we want to pass to all of the hosts in that allocation. And then we have a subscription. And a subscription is going to be a way of providing rules to an allocation. So if we select our show, we can see that the testing show has subscribed to the following allocations. And here we can also specify the amount of resources from that allocation that we want the host to have, as well as a burst amount. The burst amount is going to allow multiple shows to share a single allocation and be able to steal resources when available there. And so the next thing, if that's our way of grouping and managing hosts, services are our mechanism for grouping and managing jobs. So every job can be submitted to a service. In this case, we're looking at the Arnold service, and it's going to provide some default resource requirements for that job. The job can specify anything else it wants on top of that, but these are going to be the defaults. In this case, you're able to specify that it's going to be threadable. It's going to be able to use however many threads you want. And the minimum number of threads required, this is a percentage amount. So saying that it is 100 here means that it's going to use 1 core. You can obviously go above that. And then the maximum is set at 0, essentially saying that there's no maximum. We are also specifying minimum memory requirements for that proc. So it's only going to carve out a proc from the host if that memory is available, and if there's any GPU requirements. The last thing that the service is going to do is apply these tags to the jobs that are there. So now, putting this all together, if we go back to our Qtopia view and look at these jobs, we can select the job and look at its attributes, and we can see that it is in fact submitted to the local facility, and it's using the testing show. And then if we select our layer and look at its attributes, you'll be able to see that it's using this shell service in this case, and it's picking up the util and general tags. So with that information, we're able to figure out what allocation is eligible to run that job and what hosts it should go to. So if we go to our job that's running and select one of the frames that has finished, or one of the frames that's running, we can view the log for that job. And we'll make this a little bigger here. And so this is just the standard out and standard error from whatever process was running. In this case, it's the V-Ray log. And if we look at the succeeded one, we can search here for written image, and that's going to give us the path to the file that was actually output. We can go over here where I already have that and launch RV, and our frames are here. So that's launching and running a simple job. This is just a single layer, one command over multiple frames. Things get a lot more complicated when you start talking about dependencies and hooking up. I want a layer to wait until all the frames of one job are done, or other connections. OpenCue supports dependencies at each of the different job levels, so job, layer, and frame. And you can hook up as many of those dependencies as you want. So we jumped over here to Maya now, and I'll walk through what it looks like submitting a job with dependencies. This is from our robot dance party animation that was produced here at Next last year, and we've set it up this time for V-Ray and Maya. So it's all ready to go, and we'll launch the QSubmit plugin. Like Brennan was talking about, this is shipped as a plugin inside Maya, but you can also launch the QSubmit widget from a command line if you want, and you can configure it to run any kind of command. So we'll populate this with some information. This is just basic job info, so the job name. All this stuff is already in my history, so I'm just pressing down to populate it, and we'll do the lighting pass. And this is our Maya file that we have open. We'll select the render camera and give it a frame spec. So we'll just run frames 230 through 250. We'll set our Maya service and give it a minimum core of 4. And for this layer, we want it to run right away, so we'll go ahead and leave the dependency to none. But we'll add another layer, and we'll say that this is our FFmpeg pass. So we want to do something like run a make movie after all the frames are done, so that way we can combine everything together. And I have a command to do that over here. And we'll copy that in. And since this is just going to be a single command, we only want it to run once, and we'll say it's just going to run on frame 1. And for this, we'll leave the default service, and it's only going to consume 1 core, and we'll set it to be a layer dependency. So that's meaning that this layer is going to wait until all the frames from the lighting layer have finished, and we'll go ahead and submit. Get our confirmation, close that, and if we jump over to Qtopia, I'll refresh here and wait for our job. There's our job. Now has come in, and if we double click it, we can see that there are 2 layers here now. The lighting layer is using the Maya service, the FFmpeg is using the default one, and the frame range is associated with that. And you'll see all the frames for all the layers by default. You could filter out individual layers if you want to view just the frames from one layer, but we'll leave it like this for right now. And you can see that the lighting layers are running, and the FFmpeg layer is marked as depend, so it's going to sit there waiting until all of our running frames finish up and go. And Yeah, so a couple other things I just wanted to go over. The You saw me going up here to this Views plugin menu a lot. All of these separate widgets in QGUI are really built on a plugin structure. So it's really easy with just a little bit of Python to go in and add your own widgets. If you want to have a display that hooks up to more historical data, you can create that. If you want something that's tied into Shotgun, you can build that out as well. And that about covers it for the demo. We can switch over to the back to the presentation. And to give you just an illustration of what was going on with the dependencies, here's the dependency DAGs that were submitted. So this was the lighting render with the FFmpeg. You can see that the frames are all feeding into the layer FFmpeg layer, and that's how that dependency is working. But these kind of dependency DAGs can get pretty complicated pretty quickly. And OpenCue is going to ensure that no frames are run until after all the dependencies are met.